Hello mate and welcome to Unity beginner tutorials. If you remember in the last episode, what we did was we created this object, this rectangle, and we called it floor, and we gave it a new material, and we had a little bit of a look around our interface. What I want to do now is add another object to our scene, and simple as anything, we're just going to right click in our hierarchy and we can create. What I'm going to do is I'm going to create a new 3D object and I'm going to create a capsule. Currently the capsule is close to the camera, so what I'm going to do is I'm going to reset the position. I'm actually going to put it at position 2 meters, but on the X and Z axis I'm going to give it a position of 0. And as you can see, what we've got here is we've got a capsule collider, which is a collider that fits perfectly around the capsule shape, and it's got its mesh filter, same as our rectangle did, and it has our mesh renderer, same as that did. Now, this is all very well and good, but if this were to be an interactive object, if I was to hit play right now, what you can see is it does nothing. It just sits there and hovers in thin air, doing absolutely bugger all, because we haven't given it any properties that tell the game that it has even the laws of physics apply to it. So what we need to do is come out of our preview mode again, and we need to add a new component to it. And what we're going to add is we're going to add a rigid body to it. Nice and simple. We've got a mass, we've got drag, annular drag, use gravity. So now our object is telling Unity, I obey the laws of physics. So if we hit the play symbol now, it falls and it lays there flat on our surface. Fine. Marvelous. Great. But what use is that? Well, in its current state, it doesn't really have any uses whatsoever other than being a pretty object. So what we're going to do is we're actually going to delete it. Do that in our hierarchy view there. What I'm actually going to do is I'm going to create an empty object, and I'm going to call this one player. And it's all you can see is currently, because it's an empty game object, all it has is transforms, and I'm actually going to give it the same properties as our capsule just had, 0 to 0, but at the moment it's just a point in space. It literally is just a vertex floating in our 3D space. So what I'm going to do is I'm actually going to create a new object, and this one I'm going to call container. And then inside container, before I actually do this, before I jump ahead, what you can see is that container has position 0, 0, 0 as well, but this is 0, 0, 0 with respect to its parent. In other words, it's going to still be at 0, 2, 0 because it is at the same position as our parent object, which is at 0, 2, 0. So this is 0, 0, 0 in relation to our container object or our player object, and then the container is going to contain our 3D object, which is going to be a capsule. And the capsule can just maintain its properties for now. And what we're doing is we're basically creating an object which is going to act as our player further down the line, and we're going to add all of the logic to the container and the player properties, so that all we have to do is change the artwork afterwards, put in a 3D person with animations or whatever we want to put in there, but we can do all of the logic without needing the capsule. So what I'm going to do is I'm actually going to right click or click on the 3 dots here, and I'm going to remove the capsule collider from our capsule object, and I'm actually going to add it to our player object. I'm going to add component. I'm going to search for capsule collider. Marvelous. Nice and simple like that. Now I also need to add my rigid body to this object so that it obeys the laws of physics, same as before. But if you'll notice, if you look closely at our capsule collider, currently it's the wrong size. It's actually set to 1 meter, but our capsule is actually 2 meters tall, so we need to adjust the height. Just so that you can see why, I'm going to hit play without adjusting the capsule collider, and as you can see, it falls and sinks into the floor, which to some people might be fun, but it's not what we're after. So we're just going to come back here, we're going to change our capsule collider to height 2, and now you can see it fits all the way around our capsule, and when I hit the play button, you can see that it's now sitting perfectly on top of our floor. So now we've got a game object which we can replace the artwork later on but it's got physics applied to it and it's got a collider, so we know when it's touching the floor. Happy days. So in order to get our object here to actually do something, what we need to do is we need to start going into scripting. And I know what some of you are probably thinking, this is the bit you've been dreading, getting into scripting in Unity, but it's only C#, and Unity does a pretty good job of making it as easy as possible, so you don't need to be an expert to understand all of this sort of thing. So before I do anything else, I'm actually going to create a new folder inside my assets folder, and I'm going to call it scripts, like so. And then inside my scripts folder, I'm going to create a C# script, and we're going to call it player, just so that we know that it's the class or the script that relates to this object. And once it's had a couple of seconds to compute, you can actually see a little summary of the script in the right hand side in the inspector. That's currently what text is in there, but we'll come to that very shortly. So now we've got this script and we need to actually assign it to our player. Now there's two ways we can do this. We can either drag the script onto our player up here, or when we've got the player selected, we can drag this into the inspector, and as you can see now, the script has appeared and been assigned to the player object. So what we've just told Unity is this script that's called player, whatever this script does is going to change the properties of this object. In this case, we're looking for player input, so that's what we're doing. Now in order to edit the script, we have to double click on it. So that's what I'm going to do, double click. Now depending on what editor you have, Mono Develop might come up, or in my case, as you can see, I've got Visual Studio 2019 assigned as my Unity text editor, so that's what it's currently loading up. So here we are in our script, and we've got a load of stuff already here in already. And what I'm going to just quickly do is explain. The using statements at the top are, if you're used to using ren'py or Python, these are like your libraries. These are basically resources that you're telling C#, or in this case telling Unity, that you want to use these. If they're grayed out, it means you're not currently using them in any of your existing code, and if they are white, like in this case with Unity Engine, then it's telling you that you have something that is currently using it, which in this case is mono behavior, which is a Unity thing. And then we have two procedures, two methods inside here. We've got void start and void update. Void start is the area of code which is run as soon as the game starts. Update is run every time the game updates, or once per frame. As you can see here, start is called before the first frame update, and then update is called once per frame of the game, so that you know where to put your code. So in order to actually get our character or our player to do something, we need to provide some kind of input. Now there's no point us just checking in the void start procedure or method, because it would only do it once. What we need to do is actually give a command when we update, so every single frame of our game. And what we're going to do is we're going to check to see if the player has pressed down a key. So what we're going to do is we're going to add an if statement. We're going to ask the game if input dot get key down, there we go. And then we're going to check for a key. We need to add another set of brackets, and then we're going to just go right, like so. And then we need to add a set of curly braces so that we have an encapsulating bit of code. So if this condition has been met, if we're pressing the right key, then it's going to execute whatever key we have in here. Now, let's just test to see if we can get this working. So we're just going to put in a debug.log, and then we're going to give ourselves some text. We're just going to say right, and then we're going to put a curly, a semicolon at the end of there to say that that is the end of the line of our code. Now, if you are used to using Python or ren'py, you've not had to do this before. We use a semicolon to indicate that that is the end of our line of code, if such is relevant. For example, at the end of our if statement, because we're going into an encapsulating set of curly braces, we don't need to put a semicolon at the end of that. Same with void update, because void update is a procedure that has a set of encapsulating curly braces at the end of it. We don't need to end that with a semicolon. However, if we were to declare variables or just have mathematical functions, we need to remember to put our semicolon at the end of the line. So pressing Ctrl and S, saving our code, we can come back into Unity. What you can see is our script updates, a little bit of extra code comes in there. Now, if I were to open up the console and to hit the play button, it's going to do a bit of play. And then if I press right, you can see that right has appeared in our console. So we know that the button is actually working, which is awesome. So now we're going to go back to our code window and we're actually going to make a slight adjustment. Get key down actually asks, has the person pressed the key individually? But if the person's holding the button down, this will not register. What we actually need to do is just get rid of get key down and change it to get key. So now if the person is holding down the button, it will update constantly rather than having to keep jabbing the button over and over and over and over and over again, which is much better. I think you will agree. So what happens if we want to have different control options? I personally play with mouse and keyboard all the time, so I'm used to using A, W, S and D as my control keys. So having to move my hand over to the arrow keys is going to be a bit inconvenient for me. So what we're actually going to do is we're going to just add a space there. We're going to add 2 vertical lines, which gives us an OR statement. And then what we're going to say is input.getKey. This time we're going to go with the D key, which is the standard right. And we just have to remember to close off our brackets like that. And now I can use either the right key or the D key. And what we can do is obviously we can Control and C, copy that bit and repaste there, add a little bit of space there. This time we're going to go left and we're going to go W. This time we're going to go with left in our debug window, save our code, jump back to Unity. You can see that our code is now being updated, and then if we hit play, we can see our console. If I hold down the D key, you can see it's racking up those frames quite a bit, and if I hold down the W key, which I appreciate is the wrong key for left, but as you can see, if I hold it down, our frames update really rapidly and we end up with a message. So let's jump back to our code, and now we have to change the W key because it's actually A for left in W, A, S and D. And there we go, that's our keyboard controls set up, or rather it's doing something when we press the right key. Now that we've got that, we need to actually make it impact the player's character representation on the screen. So what I want to do is I'm going to actually add another piece of code at the very top of my script here, just inside the main class definition. And what I'm going to do is I'm going to create a new variable, and I'm going to call it a rigid body, and then we're going to call it player. Let's just give it a player rigid body like that. And then we end our line with a semicolon. But what at the moment is happening is that we've created a property that literally any other thing in the game can impact, and we don't want that. We want our player to be controlled by the player itself and nothing else. So what I'm going to do is I'm going to create this variable as a private, and what that's doing by making this private is we're making this variable only accessible to this class itself. The functions and methods within this class can adjust the properties of this, but nothing else can, which is a little bit better for what we're trying to achieve. Now that we've told the class that there is a variable, we actually need to create it, or rather instantiate it. So what we're going to do is we're going to tell player rigid body equals this dot get component, create a set of pointy brackets, and then we're going to go with rigid body, and then we're going to add a set of brackets and a semicolon at the end. And all we're doing is we're telling the class that player rigid body equals the rigid body that is associated with this class, i.e. the rigid body that's associated with the character object or the player object in Unity. because at the moment, this rigid body that we've declared here could literally just be any rigid body. We have to actually tell the class that the rigid body that we have in Unity, I.E. bear with, this one is the one that we want to use. So now we've got this created, what we actually need to do now is do something rather than just putting text on the screen. So what we're going to do is, if we press the key right, we're going to say player rigid body dot velocity, velocity being a term that you are probably used to from high school math or maybe university math or wherever you've done it, but velocity is basically a vector. So we're going to say equals there. And because we're assigning a vector, we actually need to tell it that it's going to be a vector, but it's going to be a vector 3 because we're working in 3-dimensional space. We're going to say dot there, and we're going to say right. And then we're going to terminate our line. So all we're doing is giving the vector right, which is x, y, z, 1 on the x scale, 0 on the y, and 0 on the z, to rigid body velocity. Now we can just pop that back. We can copy that bit of code, and we can paste it in there, and then we can replace right with left, and then save our script. Now when we jump back into Unity and we hit our play button, what you can see is if I jab to the right or to the left, I'm actually able to move the object. But the problem is, because it's got physics on it, it's fallen over. So in this case, our player would be face down in the dirt and being dragged along by an invisible force, which is suboptimal, shall we say. What we can do is, in the rigid body, we've got constraints, and we can actually freeze our rotations along the X, Y, and Z axis. So now if we run our game again, we can actually move our player and it will stay upright, which is a little bit better, I think you will agree. So that's nice and simple. We've created a player that we now have a little bit of control over, but I think what you'll agree with is that this is kind of meh in terms of, well, that's great, but how do we jump? How do we move faster? So on and so forth, which are all things that we're going to tackle in the next episode, hopefully. So thanks very much for watching this one, guys. I hope you found that informative and useful. Let me know what you think in the comments below. I'm sure you will. And I will see you in the next one. But until then, you take damn good care of yourselves, alright? Bye-bye.